All right, everybody. Welcome back to week 2, session 4, Monday, April 24th, 2023. It's about 6 minutes after 6 p.m. Central Time. So we're going to kick off week 2. We're going to be talking about object literals and some built-in methods on those today. So just objects. We've already talked about them a little bit in the first week, but we'll do a deeper dive into that. Any questions anyone has before I get into the slides? Okay, no problem if there aren't any. Also, just so everyone's aware, there will be a guest speaker on Wednesday, Guillermo. He is the individual who leads the pre-work. So once you fill out the application, get accepted to Code Platoon, he's also the person who grades all of the applications, the technical portions. He then leads the pre-work cohort as far as making sure everyone's staying engaged until class actually starts. And he's also one of the volunteers in the Intro to Coding channel, so he's always out there answering questions as well. And he'll be speaking with us at the start of class on Wednesday. And then the following Wednesday, we'll have Greg Drobny, who is he's kind of like the student services, the head of student services, and he will be here to talk about what it's like to apply for Code Platoon and some of the different ways to finance that, be it Vet Tech or the GI Bill or one of Code Platoon scholarships that they offer. And he'll be able to answer questions about that. All right, so let's go ahead, hop into the slides. And again, we're going to be talking about object literals, or just objects. What is an object literal? Is a data type that holds a collection of properties where each property is an association between a name, which is a key, and a value. So we've already talked about these. These are, we use curly braces to define an object, and we give them key value pairs. There's no index value inside of a object, so there's no like 0 index or 1 index or 2 index. There's just key names, and we can basically locate the values by the key names. And so it looks like we've just got a basic example of a person here, so let's go ahead and do that. We'll just say let person equal, and again we've got opening curly braces, and so we can say first name Charles, last name Kubiak, hair color brown. And so these are all string values. So we can say, we can also store numbers as a value. We can store nested objects in here. We can also store we'll just call it so we can do arrays, we can do additional objects that like nested objects. So we could say something like food, say burrito. Let's see here, color, red, pastime. All right, and then we could also do a array in here. Let's see this. All right, and so if we send this to the console, so if we do console.log person, all right, we're going to get the entire thing. Oops, pets, because I did not put a comma here. All values have to be comma separated. All right, so there's the entire object. And I can act, because I have all one word values, I could access, or I'm sorry, key names. I can access the values using dot notation. So I could do first name. right? And so I get that, or I can do it in bracket notation. Right. So these both do the same thing. All right. And an object literal keys and values not have to just be string data types. It can be all other types as well. So again, just like what we talked about. And again, there is no, eventually you can run a computer out of memory if you give it something big enough. But for practical purposes, there is no real limit to what you can store in here. So like this is an object, this is a nested object inside it. We could keep nesting more and more objects deeper and deeper. And realistically, we can nest things deeper and more complicated than what is practical. If you find yourself nesting like 5, 6 layers down, then you may need to rethink about how you're storing your data. All right, so interacting with objects, right? So we just talked about this. So you can access by the key with the dot syntax or the dot notation or the bracket notation, right? And you can also basically determine if a key is in there a couple of different ways. There's a built-in method called dot has own property, and then also you can just use the word in as far as logic comparison. So we could say console.log person dot has own property, and if we say, I think I need to put this in quotes here. We'll try this first. We'll try hair color. This should resolve to true. Right. And there's our true. And if I did something like this, height, which there is no key height in here, that's going to return false. All right. And so that can also be done with the in, right? So like we could say name in organization. So we could say, well, let's see if this works outside of an if statement. I feel good because it turned my in blue so that it recognizes it. And we'll say in person. And let's see what happens. Right. So true. Right. And so again, all right. And let's see here. So with objects, there are a couple of different ways that these get formatted. So we have the object has own property, returns a Boolean, true, false. We can also get all of the keys that are inside an object. We can get all of the values that are inside an object. And then we can get all of the key value pairs basically returned in an array. So we could say console.log person.keys. Person.keys is not a function. Did I put that in wrong? Object.keys. And so this is what I meant when they're formatted a little bit different, than I went and screwed it up. So If we're going to do something like an array, right? So if we do let array equal 1, 2, 3, 4, 5, and then I want to know the length of that array, I need to do array.length, right? And that will give us our length right there. With an object, we need to do object. So we're actually doing it on the object class.keys, and then we're feeding it the object name. Right. And so there are all of the keys for that top level object person. Right. And if we do console.log object.values and we give it the object, comment this out for right now. Okay, there's all of the values in an array. And then lastly, we can do object.entries. Whoops. And there is all of our, so basically we've got a nested array. So each array inside the top level array is the key and the value. All right. So any questions on how any of these three built-ins work? Okay, so that's it for the slides for session 4 today. So now we can hop into the challenges. As a class, would everyone like to split up into groups? We could do pairs or groups of 3 or 4 and go through a challenge, or would you like me to lead the first challenge and then we'll split up into an additional one?
Maybe go through one and then do the breakout groups like you did last time of 3 or 4.
Sounds
That's my vote.
Oh, don't need to create a new upload, sorry. All right, so let's go ahead and take a look here. I believe, let me just look back at the intro to coding channel here. So we finished on remove zeros. It's right here. So we've got alphabet code. So let's take a look at that one and see if this will be a good one. All right. And then show code. All right, so write a method that takes in an uppercase letter of an alphabet as a string and returns an integer corresponding to the place in the alphabet. All right, so that sounds like that one shouldn't be too terrible, but let's go ahead and do that. Fork the replet. Get all of these pop-ups. All right, so let me pull this back up and grab prep code block. Let me just do this one. Let's go ahead and pin that to the channel. So that is there for all time. All right. Cool. All righty. So let's go ahead and pop in the prep code block. Let's pull over this stuff. But remember, grabbing a chunk of code, and you can see whenever you highlight some text on here, it highlights all of the matching code on the rest of the page. Control D on a PC, Command D on a Mac will start to give you multiple cursors. So that you can do that and enter in multiple things at the same time. It's just a way to speed things up a little bit. These. All right. And let's go ahead and run this real quick. And I get my 3 falses, so I'm feeling pretty good about that. All right. So we're going to write a method that takes in an uppercase letter of the alphabet as a string and returns the integer corresponding to its place in the alphabet. All right. And so we have one input, right? And that is going to be a string, a single uppercase letter. And we're going to have a return here, which is going to be one number representing letters placed in the alphabet. And passages being a number, it is going to be an integer. Right, we know that. No half numbers in the alphabet. Right, so we have 3 examples below. Right, and so pseudocode here. Okay, so what are some ways that we could store the all the different index positions of the alphabet letters? Anyone want to take a stab at that?
Would we just maybe declare a string of all the letters together?
So do something like this.
Yeah, yep.
Okay. Yep, that's absolutely one way to do it, and probably the most efficient way to do it. What's another way that we could do it? And there's really 3 ways that we could do this, right? And the doing it as a string is probably the least amount of typing. The next would be an array, right? Where we do A, B, C, and then probably the most complicated way to do it would be doing it as an object, right? Where we do something like this, A, right? And so all 3 of these ways would work, but this is by far the least amount of typing, right? Because I don't have to put each individual letter in quotes, so on and so forth. And here, I mean, you've got the colon, everything's comma separated. It becomes a big mess, right? So I would say that doing it as a string would be the best way to do it. All right, so just delete these. All right, and so what do we, and doing this in a string, what do we know about strings that allows us to do this? Strings have what?
An index of.
Yep, strings have index positions, right? I'm not sure if there is a explicit index of on string, so let's go ahead and look that up. So MDN string. All the built-ins are on the left-hand side, and they're always in alphabetical order. So we've got string.prototype.index of, right? So the index of method gives one argument, a substring to each for searches. Wow, sorry, I butchered that sentence. The index of method, given one argument, a substring to search for, searches the entire calling string and returns the index of the first occurrence of the specified substring. Given a second argument, a number, the method returns the first occurrence of the specified substring at an index greater than or equal to the specified number. So just reading that, we shouldn't need the position because our string is going to be one of each letter. So it's not like an actual sentence or anything like that. And we should be able to do index of. So if we do alphabet dot index of letter, this should get us one step closer. Right, so 0, 1, 25, -1. All right, so it looks like we're off by 1 here, right? So we got a 0 for A because every computer start counting from 0. So we could do the index of letter +1, and it will be the same each time. All right, so now we've got 1, 2, 26, and 0. And this is going to be an issue right here because I did this as a lowercase c, and the computer differentiates between uppercase and lowercase. So let's go ahead. We know we can take this out of the console.log and we can put this into our return. And this should be the answer that we're looking for the first 3, right? So we've got true, 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 and false. And to take care of this, what we need to do is take the letter and move it to uppercase. And it's not specifically asking us to do this in this challenge, but we know if it says every time it's looking for uppercase, it doesn't hurt to add a little bit of prevention in there, especially if this was something a user was typing in, and we can't really control what they type in. And we can do 2 uppercase, and I think uppercase is 2 words. Yep. So we do that. All right, so now we've got true, 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 and true. So we're solving for everything, even when we give it a lowercase. So we can get rid of this console.log. We'll do that over here. Go ahead and run it. And there's all of our truths. So not too terrible to solve this one. All right, so let's go ahead. And so any questions on any of the steps that I took or how I solved this? Okay, so let's go ahead and take a look at another one here. Let's go ahead. Rectangle, we'll skip over that. Average velocity. I don't think that one's very exciting either. Okay, actually, we will do average velocity. This will be a good one. So write a method that takes in an array of positions over time and the total change in time and return the average velocity of the entire trip. Time will always be greater than 0. So average velocity is equal to the change in position divided by the change in time. Change in position is equal to last position minus first position. All right, and so we have an example of 0, 4, and 6, and then the amount of time that is coming in a separate. So right, we've got the position array and then time, and so this would be a difference of 6, right? So we're only concerned with the first and last element in the array, and then divide that by the amount of time that we have. So the first one is 0.6, and then the next one is 3 to 7, and so we have 4 would be the difference between 3 and 7, and that is divided by 4, so we get 1. All right, so you'll want to fork this one, and what I'll do here is it looks like we've got 3, 6, 7 people, so I will do a group of 3 and a group of 4, and this one shouldn't be too lengthy. So if anyone has any questions for me, feel free to ask them now about the challenge. If there are no questions, then I'm going to move us into the breakout rooms. I'm going to give everyone about 10 or 12 minutes to take a stab at this one. All right, any questions about this? All right, welcome back from the average velocity challenge. So I've got a solution worked up here, and I'm going to go ahead and run through this here real quick. So for this, we need to write a function that is going to take in an array of different position changes and a unit of time, a measurement of time. So we've got 2 parameters, the position array and the time. And we need one return, which is going to be a number. So either a float or an int, depending on how it works out. When we look down here on lines 23, 24, we've got a 0.6 and a 1. Right, so it could be either one of those, depending on how the math works out. Now we've got a couple of examples down here. And the steps that we're going to need to work through with this one to get the answer is we need to identify the first and last element in the array of positions provided. We'll need the absolute value of the difference between the starting position and the ending position. So again, the first and last element in that pause array. And we'll then need to return the difference of those two divided by the amount of time that has passed. So we're going to be looking at something that is going to be AVS, or the absolute value of the start minus the end, divided by the amount of time that has passed. And so with something like this, again, with the starting position in the index, or I'm sorry, in the array is easy because it's 0, that is never going to change. However, we will have different length arrays, and one of the ways to always get the last element in the array is to take the length of the array minus 1. Right? And that is because the index value is always the 0, or we always start counting index values from 0. So this has an index of 0, 1, and 2, and it has a length of 3. So if we don't do that minus 1, we would get 3, and I'll just delete this out here real quick, and let's go ahead and do this as a console.log so we can see what it looks like in the console. All right, we get not a number. And the reason being here is because this gets turned into a undefined, right? Because we're looking for something in the, if we just take the length of 3, we're looking in the index position 3, nothing's there. index position 0, 1, and 2. So we add that -1 back in there. And so something that has a length of 3, we would be going to the 2 index position. Something with a length of 4, we'd be going to the 3 index position. So again, 0, 1, 2, and 3. Right. And that is always going to give us the last index position of the array, regardless of length. So it doesn't matter if there's 3 in there or there's 3 million. We're always going to get the last element by doing it this way. And because it doesn't specifically spell out that these numbers, what order they would come in, that they're going to be like sequentially getting higher. And so in the case of 0 and 6, right? So if we take the starting position minus the ending position, that would give us a -6, right? If they were flip-flopped, it would give us a +6. But for us, we want velocity to always be positive. So that's where we're going to use the math module, and the absolute value of the math module will wrap the subtraction here. So the starting position minus the ending position, and we're always going to get a positive number. So the absolute difference between these two numbers, regardless if the plain subtraction would just give us a positive or negative number, this is always going to give us a positive number. We can then divide that by the unit of time that has passed, or the units of time that has passed, and then we'll return that. And so I can take this, we'll leave the console.log in here real quick, and we'll see that we get 0.6, 0.6, 1, and 1, and we get true for all of those. So I'll just leave this in here and I'll comment that out. All right. And so that is the average velocity challenge. We're going to take a short break here. So I'm going to pause the recording and we'll start back up when we come back to class. Using recording. All right. Well, welcome back from the break. We're going to jump right into our next challenge, and we'll tackle this one in groups, and I'll try and give a little more time. I'll actually probably give about 25 minutes for this one. This one's a little bit more difficult. And so, like I said, each one of these is going to ramp up a little more complicated than the one before it. And this one is the illegal word challenge. So it's about like the 10th one down the list here on the first page. And we're going to write a function that takes a sentence and an illegal word and returns a Boolean indicating whether or not the sentence contains the illegal word. Capitalization should not matter. So that's a hint right there on something that you're going to need to do to tackle this successfully. Do you want to work in the same groups, or do you want me to scramble the groups?
Same for the night, I guess, would be fine. I mean,
Okay.
that's my vote.
Not a problem. So does anyone have any questions about this one before I break everyone out into teams? We've got 2 teams of 3 right now. All right, so let me go ahead and open up the breakout rooms. Sharing is enabled. If anyone has any questions, or if you complete this ahead of time, so at 7:17, we'll say I will pull everyone back in around 7:45, unless I get messages saying that both groups are done beforehand. And if you get completely stuck, feel free to message me and I'll try and jump in the room to see if I can help you get unstuck. All right, so let me just go ahead and pause the recording. All right, everyone, welcome back from the illegal word challenge. So it looked like I got messages from both groups that everyone finished, which is great. So I appreciate everyone chiming in so that we can manage our time. We finished about 5-6 minutes early, so means hopefully we'll have a little more time to get an extra challenge in throughout the evening. 1 second here while I get my screen all set up. All right, so we've got our prep copied over. Let me grab the README. Got the test down here. All right, so we'll just leave that alone for now. Up or down, dude? Sorry, I've got a cat trying to knock things off my desk so you can clear a path to get on my lap. All right. I'm gonna go ahead and run this. We should get also we got true, undefined, undefined. So we got going on here. I don't think that's the way that we want this. Do this. All right, 3 falses. That's what we're looking for. All right, so we're going to get 2 parameters here. Both of them are strings. So sentence, string, and word is a string. All right, so we are going to return a Boolean. All right, we've got examples below. All right, so write a function that takes in a sentence and an illegal word and returns a Boolean indicating whether or not the sentence contains the illegal word. Capitalization should not matter. So I know you need to Okay, so I think that's a good start, right? So I need to figure out how to identify the word if the word is located in the sentence. Search is case sensitive. I know that from previous examples. So we're either going to downcase both of these parameters or we're going to upcase both the parameters. It doesn't matter which direction we go as long as they're both going in the same direction. And then I need a way to look up, basically search the sentence. And I'm wondering if I can do this with like a string index of, if there's a way to do that, or if I need to break this into an array and then loop through it. I know both teams finished this. Did you end up using an array or were you able to do this with an index of search in the string? How did you guys tackle it?
We looked at it 2 different ways. We used the index of in a ternary function or ternary operation, and then we also used a I think we did a includes method.
All right, so let's go ahead and look that up then. So let's say mdn dot includes. Okay, so it looks like there is an array includes and there's also a string includes. So this brings up a really good point. If we can, both ways of solving it is perfectly fine. Whether you did it with an array or you did it with a string, both ways are right. However, in my head, I'm thinking if I don't, I'm already given strings. So if I don't have to split the string into an array and then loop through the array, or use it dot includes, like just doing it basically in keeping the data type a string saves me some steps, right? So either one would be a valid answer, but this would be the quickest way to do it. So let's go ahead and take a look here. And sorry, what I was going to point out is when we search for things, sometimes it's not always the top answer, right? Like if you have to go to, I would say, if you end up going off the first page of results, then you maybe want to try a different search or kind of refine your search. But it'll be very common when you're doing software development that the first result isn't necessarily the one you're looking for. A lot of times it is, but something like this, like if I was saying, hey, mdm.includes, I want to break this apart. I just look at this and I just go straight for it. I'm still going to get an answer I can use, but this is probably going to be the better answer at this point. All right, so we can say we have a sentence, the quick brown fox jumps over the lazy dog. We've got a word, fox, and then they've got some extra stuff around this, but we've got is not, all right? So we should see an is in here, right? Is in the sentence. We just need to return a true or false. So we don't necessarily need to do all of the fancy stuff with the template literal here and making this human readable. We're just going to return a Boolean value. But this dot include looks like a good way to do it. I think index of would be a good way to do it as well, mainly because it says that a substring, so a substring doesn't necessarily have to be a single character. It can be any part of this is a substring. I mean, technically all the way up to the entire string is a substring. And it's so if we're just looking for a word inside of a sentence, we're looking that this is going to work as well. And then it's either going to give us a string or it's going to give us a number. This is the index value of what you're looking for, where it starts. Or if it doesn't exist, we know we're going to get a -1, right? So like we know dog is in here, right? And so, but if I say dogs, right, I get -1. And so, and that's anything that's not in there is always going to give me -1. So I could then translate that -1 into a false value, and everything besides -1 would become a true value. But I like the dot includes because that's going to, again, where either one is a perfectly fine answer, but using the dot includes skips me right to true or false, right? And so when we come in here, we could say something like this, right? So we could say console.log sentence dot includes word, right? Like this will be our first pass at it, right? And let me do this. We'll put a 17 in here just so that we've got all these true and falses mixed together with each other. Let's just make this a little more readable. So we know these ones are coming from line 17, right? So we get a false, which is we want it to be false. This is true. And we've still got the issue here where we know that this is the word fudge and we're looking for it. But now we need to start doing some either upcasing or downcasing, right? So I can say sentence dot to lowercase dot includes word dot to lowercase. All right, so now we've got a false, a true, and a true. So this is looking pretty good to me, right? And we could do something, like I said, so we could say console.log. I'll do it underneath it here. So we could do console.log. Oh, wow. Console.log, and we'll say this is 18, right? And we could say something like this where sentence dot to lowercase dot index of, and then we can say word dot to lowercase, right? And So we get a -1, a 17, and a 17, right? And so we could do something again along the lines of this, where we say a ternary. So is this equal to -1, right? And yeah, and actually we don't even need a ternary here. We can just say -1, right? And this is going to go to true or false. And we actually want to invert this, right? So this becomes a false. This is false and false. So this isn't something that, what am I doing wrong here? Taking too many steps at the same time. All right, so true, false, false. Okay, so -1, 17, and 17.
Yes, because if it doesn't equal -1, we would want not equal equals -1, right?
Yes. Yeah, and I was trying to invert the entire thing, so you're correct. I put that in the wrong spot. So this would do it the right way. So false, true, true. So you can see this ends up just being a little bit more code than doing it this way. And so this would be like the long way around. And if we wanted to go even longer, right, we could look at something where we say let array equal sentence dot split. And we can split on each word, right? And then if we look at this console.log array, right? So we've got, oh, I'm sorry, I don't want to split on every character. I want to split on the space, right? So there's that. And now I could do a dot includes in the array, or I could look at something where I write a loop and basically compare each word in here for the word that I'm looking against. And the reason that I show you something like this is mainly for interview purposes, because what's going to happen, and not in every interview, but a common interview tactic is to give you a challenge like this. And then they're going to say, hey, can you solve this for me? Right? And you may jump right to this. And they're going to say, okay, that's using built-ins. Can you solve this using a loop? Right? And then they're going to ask you to basically demonstrate that you know how a loop works, right? Or you're going to solve it by splitting it into an array and looping through it. And they're going to say, okay, great. Now, can you show me how you would solve this without using a loop, right? Without having to write an explicit like for or while loop to get through this. And so what happens with a lot of these challenges is you walk in and basically like there's a very simple, straightforward challenge, and they may nix that right from the get-go, right? Like they may say, hey, I want you to solve this, but I need you to solve it with a for loop, right? Just explicit right from the get-go. Or you may allot a half hour for the technical challenge, and you get to the solution in 5 minutes and you've got 25 minutes left. Then they're going to start poking and prodding at you and asking you to do other things with it, because they're going to fill that time. They usually don't end a technical challenge early, like, oh, you solved the problem, that's it, we're done. They're going to say, like, what are some of the next steps that you can take with this? Or they may have like an additional layer of difficulty that they're going to hit you with. And so that's why usually with these, like, I'll discuss the different ways of solving these, just like the last one where, hey, return that index, and you start off with an array. Hey, can you solve this problem, the alphabet index, without using an array? Or can you solve it using an array, right? And they're going to have you continue to demonstrate problem solving. All right. So, and just, I mean, if anyone was interested in it, so it'd be something like for let I equal 0, I less than array dot length, I plus plus. And we could say at any time if console log these out or comment those out, comment this out. We could say if array I is triple equal to word, and let's do this as well. Let's do dot two lowercase. We'll just take care of that right up front. Then we can say this doesn't need to be quotes to lowercase. Right? If that happens anywhere in here, we're going to return true. And if no words ever match, we can leave the for loop and we'll return false. Right. And so now when we run this, right, we get all of our trues. Right. And so we can say console.log true. Right, so we loop through, we never match, we hit our false, we loop through, we hit our true, we loop through, we hit our true, right? So this is solving it the exact same way as these two. This one would be the answer that I would go with, right? And we can comment from there to there out. And so we'll say solve with index of solve with a for loop. All right, so there's 3 different ways to solve this. All right, and there's our true. So that's the solution for all of those. So any questions on how I solve the different solve these the different ways? Okay, so it is 8 o'clock. Let's go ahead. It's 7:59. So let's go ahead and take a 6-minute break. We'll come back at 8:05. We'll answer any questions anyone has, and then we should have enough time to maybe we'll split into groups one more time, do a challenge, and then come back and explain it through class, and that'll get us through the end of class tonight. So go ahead and take a break. I'm going to pause the recording. All right, everyone, welcome back from the break. So we're going to look at probably the last challenge for the night, depending on timing. So we're going to take a look at caffeine control, and we're going to break back out into our groups again. We'll leave the groups the same. And I'll give everyone, we'll say the same amount of time, 25 minutes, because by the time we get done explaining this, that'll put us at about 8:35 or so, give or take. How you do with it, and then my explanation, and then that should put us up to right around 9 o'clock or so. All right, so every weekday you drink caffeine to get ready for the morning. Monday you need 800 milligrams to wake up from the weekend. Tuesday you only need 600 milligrams. Wednesday and Thursday you only need 400 milligrams, but on Fridays you're going to party hard. So you drink 900 milligrams of caffeine because you know you'll be staying up late and going out with friends. You prefer buying small energy drinks that contain 150 milligrams of caffeine each. Write a method that takes in the day as a string and returns the minimum amount of caffeine drinks you'll need to buy. Right. And so the minimum amount, so like if we look at the example here of Monday, right, and On Monday, we know we need 800 milligrams, and it's telling us 6. 6 times 150 is 900, right? So it's basically you are always going to go over to the next largest whole number, right? We're always going to be rounding up with these. Right, so Thursday, which is an R, you only need 400. You're going to have to buy 3 of them. It's 450 total. Again, because 300 won't cut it. Any questions about this one before I split everyone back out into the breakout rooms? All right, so same as previously. If you finish early or if you get stuck and you need some help, feel free to send me a Slack message, either directly or at me in the intro to coding, and I'll hop into the room. But outside of that, let me go ahead and pause. All right, everyone, welcome back from the caffeine control flow and types challenge. Spoke with both teams, and it looks like everyone solved this in a couple of different ways. So we'll go over a couple of different ways here in class, and there's definitely more than 2 ways to solve this. So we'll see how everyone tackled it, and maybe we'll come up with 2 or 3 different answers for this. All right, so the challenge is, it states every weekday you drink caffeine to get ready for the morning. Monday, you need 800. Tuesday, you need 600. Wednesday and Thursday, you only need 400. And Fridays, you need 900. And you prefer buying small energy drinks that contain 150 milligrams of caffeine each. Write a method that takes in a day as a string and returns the minimum amount of caffeine drinks you'll need to buy. All right, so we're going to have one parameter, which is going to be a string, which is going to represent a day of the week. So Monday, Tuesday, Wednesday, Thursday, and Friday. All right, we're going to return one parameter, which is going to be the number of drinks you need to buy to reach that day's caffeine requirements. All right, example, so see below. All right, so let's take a look at some pseudocode here, right? And so if we look at this, basically, we know that we're going to have a day and a corresponding caffeine value, right? And so for us, that sounds a lot like a key value pair. So right off the top of my head, I'm thinking like, hey, maybe we can store the day of the week and the amount of caffeine for each day right in an object, and that would make things nice and simple. The other way I'm thinking that we could solve this is we could use some sort of conditional logic, so like a chained if else statement, or even a switch statement, which isn't something we've discussed in class yet, but I think both teams were able to pick up on those, right? So that's using conditional logic, and there's a couple of different ways that we could iterate through that conditional logic. All right, so steps to solve. Excuse me. All right, and so regardless of if we use an object or we use some conditional logic, we're going to need to divide that value that we get back by 150, and we're always going to want to round up. So maybe there's a trick we can do to take care of that for us. Maybe there's something in the math library, so the math dot whatever, just like when we were using math dot ABS, that'll help us round up every time, so that we are always getting the next highest whole integer for that. And that's stated in the problem right here. So write a method that takes in the day as a string and returns the minimum amount of caffeine drinks you'll need to buy. All right, so let's go ahead and console.log day just to make sure that we're getting what we think we're getting within our parameters, right? So there's Monday and there's Thursday. So that's a good start. So let's go ahead and say, what do we want to call our object? We can say caffeine. Spell that out. E, except after C, and apparently in caffeine, unless it's just being spelled wrong across the board. Let's say an object, right? And so we have Monday is going to be 800. Oops, give myself a comma. Tuesday is going to be 600. Wednesday is going to be 400. Thursday is going to be 400, and Friday is going to be 900. So I'm missing my colon here. All right, and let's take a look. So clear but never read. All right, and so how do we get to the value with the corresponding day? Like, what do I need to send to the console to see that? Anyone want to take a stab at that?
You're going to need to divide the value, the caffeine.
Well, that's a step ahead. How do I just, what do I need to type in here? So like if I'm getting Monday and I want to see 800, what do I need to type on line 25?
Caffeine, square bracket, and day.
All right, let's give that a shot. All right, I see 800 and 400, 800 for Monday, 400 for Thursday. So excellent. Yep. So again, we want to take a one step at a time. So now I know that I'm accessing my object the right way. Excuse me, accessing my object the right way. So now the next step is to divide it by 150, right? So we can divide this by 150. All right, now we've got 5.33 and 2.66. So now we've got a little bit of an issue because we're getting floats and we want the next whole integer. So what is a way that someone worked their way through this? Do you use a built-in?
We used a built-in. We somebody in our group had suggested, and so we looked up under math, and we did MDN JavaScript round up, and then in our search result, it actually came up with math.ceil.
Okay, so math.ceil static method always rounds up and returns the smaller integer greater than or equal to the given number, right? So doesn't matter if it's 7.004, right? Just like a thousandth of a whole integer, it's still going to round it up to 8, which is exactly what we're looking for. All right, so let's go ahead and we're going to take this whole thing and we're going to wrap it in math.ceil. All right, and let's go and run it. So I get a 6 and a 3. That looks pretty good to me. Let's go ahead and throw in a Friday here. And Friday for 900, I believe I'm going to need 6 cans as well. So I should get a 6 again. There's my 6. All right, so we're looking good and we're not returning it, so everything's still false, but knowing that this is what I need, I can go ahead and return this. Oops, return, because I'm missing the space. There we go, we get our trues. Right, so this is definitely, this is how, this again would be the preferred solution. Right, but the other way would be, and again, because this is the smallest amount of code, technically this is just 2 lines. I'm spreading this out over multiple lines, but I could put all of this up on 1 line if I wanted to. It would just be 2 lines of code in here for the solution, the object, and then what we're dealing with the object. Now, the other thing we can do here is let's go ahead and comment this out for right now. Copy it, comment it out. And the other way we could look at solving this is with some conditional logic, right? So I'll leave this here for right now. So we know that we have day coming in, and so we could say something like this. So we could say if day is triple equal to m, right, then we could say, well, let's just say, let's just declare a variable up here. Right, we'll just instantiate it, but we won't do anything with it yet. And so we'll say 800, and we'll say else if day is triple equal to t, right? We can say caffeine is equal to 600, right? And now we could say else if day is triple equal to Wednesday. And we could do a little bit of cleanup here because it could technically, if day is triple equal to Thursday, right, these are both the same thing. So we could say caffeine is equal to 400. Right, and then lastly, we could say day is triple equal to Friday. Right, and then we could say caffeine is equal to 900. All right, so we can get rid of this now.
Would you
And
want to
then-
write that last else if as an else?
Not really. And the reason I say that is because what if I do this, right, then if I just do this as an else, oh, sorry, because I have not,
You forgot Thursday.
yep, I didn't put the quotes around it, and then this is going to be, I don't need the day here anymore, I just need that. All right, but see, this falls through, and this is not a day of the week, but we still get an answer. So I would be explicit with this and say else if,
Okay.
right, so like day triple equals Friday, then do it, and then we could definitely do an else, right, where we say something like return that is not a valid day of the week,
Yeah.
right?
Perfect.
And
Yep.
so now we're doing some improvements, and I'm going to show you some other improvements that we can do with this as well. And we could do the same thing up here as well, right? So we could put a guard clause in here that if it's not one of these, right, that we don't necessarily return this. We return some sort of an error message. And because now, if I get rid of this true false thing here, right, like I would actually be returning that is not a valid day of the week, which is what we would be looking for. Right, and so we could do something like this. Copy. right? And so now we're getting true. So that's what we're getting across the board, right? And outside of just doing it like this, again, same thing. So to do something here, and we could do something called a switch statement, right? And so this is just a it's another way of doing a if statement. And so this is basically saying, if this, then do this. And we need breaks in here if we're not returning, because if we're returning, that is the last thing that happens. But like with this, with the console.log, if you don't have a break, what happens in a case statement is once it hits the first true case statement, there's no break there. It'll run through all the other cases as well. And it's called falling through. And we prevent falling through by putting breaks into each case. And technically, even though you don't need them with a return, and I don't know if it'll yell at you and say that it's unreachable code or not, but it's just a good habit to get into, right? And so with the case statement, like I said, it's very similar to the if statement, right? So we could say, or I'm sorry, when I say case statement, I mean a switch statement. I verbally screw those up sometimes, right? So we could say switch, right? And we could say day. And instead of if, we're going to do case, right? And instead of curly braces, we're going to do a colon, right? And we can still assign the value of caffeine here. We can break, right? And same thing. Case. Oops. Let me just make sure I'm writing this correctly. Yeah, the colon comes after it. And I don't need the parens. Well, actually, I think I can leave the parens in there. Actually, oh, what am I doing? I'm screwing this up. Sorry. Okay, so we get the expression. And so it's just going to pass through. So we don't need any equals in here. That's what I get for not just writing it.
Yeah, because I think the switch is also has the appearance of an object literal.
Right. Yep. I just got sloppy because I was trying to convert it. Oh boy, what are we yelling at me about? Thursday, what, 600? I honestly can't even tell which one's further ahead at this point.
So the Wednesday and the Thursday, similar to the or statement in your if else, you don't need to put a value under Wednesday and just let it fall through to Thursday for this before the break.
Correct, and that's exactly what this is demonstrating.
Okay, cool.
Switch. That's where I'm screwing up. That's why it looks so weird. This, I still need the curly braces for the switch itself. Let's do that. Sorry. This will hopefully come together. I'm sorry I made this so ugly. Okay, so we should be about there. So there's the case. What's the error message here? Expected. So that's there. It's that. And
Case should be indented from the switch.
that should be happening automatically. There's something else causing it. Opening, closing, break. Sorry.
Do you need the default?
You don't have to have a default, but we will definitely do one, which would be, again, the same thing. Where we say this is not a valid day of the week. Right, and this could be a return. Switch day. It's just a string. I don't know why this is so mad at me. Well, maybe it was just pretending to be mad at me. All right, so everything else commented out. Let's see. We'll either get some answers or we'll get some error messages. Okay, so we got true, true, false. Boop-a-doo. Let's go ahead and is not a valid day of the week. Because I said this, not that. There we go. And I apologize because that was a truly atrocious conversion of doing that. I should have just written it from scratch. But at the end of the day, this does the exact same thing as this. All right. And it also takes us to about 8:59. So that is pretty much the end of class. Again, sorry if I introduced any confusion in the way that I converted this over. But that would be 3 different ways to solve this problem. This, I would say, would be the preferred way. And then probably after that, the switch statement. And then after that, it would be the using the if else. All right. So that's it for the end of class. Do we have any questions about any of these 3 solutions? Okay, so I'm going to stop the recording